Let's go ahead and continue and finish up page 3 here on Module 7, Lesson 3. So we have a new scenario here. Oh, I remember at the end of the last video I was explaining, so in 1960 the average lifespan was 70 years, but I was pointing out that don't forget every year after that it increases by 0.3. So in 1961 the average lifespan would be 70.3 years. In 1962, the average lifespan would be 70.6 years. So each year after 1960, the lifespan goes up. Okay, so now let's look at number 2. Number 2, we have V equals 64 minus 32t. So V is the velocity of the ball, and really that should be a capital V because that's our y. And you can always tell y equals mx plus b in feet per second. We need that. And t is the number of seconds after the ball is thrown. So it's how fast the ball is going t seconds after it's thrown. So what is the slope? So the first thing you probably want to do is turn this around so it looks like a regular equation. Do you see how the x variable, because this is your y, is not first? So when you turn it around, you just have to be sure and carry the sign with it. So it's negative 32t. And then 64 doesn't have a sign in front of it. That means it's positive. Because lots of times I notice when students leave it in that form, then they think this is a slope and this is a y-intercept. You always have to have the variable term first, because whatever's in front of the variable, that's the slope. So the slope is negative 32. So this is our y, this is our m, this is our x, this is our b. So now you see why I turned it around so it mimics y equals mx plus b. What is, oops, and we have to label it, because remember slope gets labeled y per x, oops, per x. So y is our v, so that would be feet per second, and t is seconds. So have you ever used or heard the phrase feet per second per second? It's also called feet per second squared, but that's what this is going to be because it's y, feet per second. So that's our y. Then we use the word per again, and then second. So this is how many feet are covered at every second, and then this is per second. So feet per second, or sometimes it's referred to as feet per second squared. So it doesn't matter how weird it sounds, you just always have to follow that pattern. So y is feet per second, then we use the word per, x is second, and you can tell x is t, so feet per second per second. So what is the meaning of the slope? So the velocity of the ball is, what's that mean? We can't say negative, so we could say decreasing. Is that a good word for it? So the velocity of the ball is decreasing by 32 feet per second per second. So the velocity of the ball is, and then to use that we'd say decreasing instead of the negative sign by 32 feet per second per second. t equals 0. Okay, so t is our x. So this is saying when x equals 0. So that tells me I'm finding the y-intercept. And we know the y-intercept is 64, because if you put 0 in here, right, you get 0 plus 64. So this would be 0 comma 64. So b equals 64. And it would be feet per second. Oh, and I think up here I forgot to write L is years. Yep, I did, because they told us to label these, so add years in up there. So the lifespan is 70 years. I don't know why I thought of that, but I was looking for the label here and I thought, oh, I didn't do the label up there. So V is feet per second. So 64 feet per second. What is the meaning of this? So take your point and remember how we did on the last page, and I said label what each point stands for. So 0 is my x, that'd be number of seconds. So this would be like 0 seconds, or at the beginning, or initially. That's usually the word they use in these physics problems. Initially. So if it was 1, you'd say after 1 second. If it was 2, after 2 seconds. But it's 0, so that means initially, right at the beginning, right when the ball is thrown. It is traveling at a velocity of 64 feet per second. So now we can easily, now that we got the labels on it, we can easily write a sentence. So when the ball is initially released, it is traveling at a velocity of 64 feet per second. So initially, or you could say at the beginning, or whatever word you want to use, the ball is traveling at 64 feet per second. Or you could say the ball's velocity is 64 feet per second. So anything like that. At the beginning, the ball's velocity is 64 feet per second. Initially, the ball is traveling at 64 feet per second. But so many students struggle with this on the test. They find this answer and then they can't write about it. All you have to do is look up and see what is x. X is our t. Label that. So that's the seconds. And what is our y? V is a velocity in feet per second. So label that, and then you can easily write a sentence. Talk about this and then talk about that. So now would be a good time to turn off the video and try number 3 on your own. And this is kind of hard for students at the beginning. I think it gets easier as we go, but this is the first time we've seen this and talked about it. So it's not super easy, but I think it'll get easier as you go. So go ahead and try 3 and then join me and we'll go over it together and check it. Okay, so the fishermen have been recording the number of dead fish they encounter while fishing in Lake Superior. This data can be modeled by the equation where D is the number of fish deaths per year and P is the population index. So let's again make this a capital D because this is our Y. So y equals mx plus b. So you can see they're using d in place of y, and they're using p in place of x. So what is the slope? It's always the number in front of the variable. So it's 8.5 113. And remember, we have to use y per x when we label slope. Because otherwise, if you just write that, you'll have no idea what that means. But if you write the y per x on it, then all of a sudden it comes to life and you're like, oh, I know what that means. So y is our d. So that would be number of fish deaths or fish deaths per year per pollution increase in the pollution index. So, and it's increasing. So the number of fish deaths, because this is positive, is increasing by 8.113 deaths per year per pollution index. So that's what we would write here. Well, first we got to label it. So it would be fish deaths per year per pollution index, because it's y per x, and x is p. So fish deaths per year. So that's my y. Then I put the word per in, and then the x, pollution index. So y, fish deaths per year per pollution index. What is the meaning of the slope? So the fish deaths are increasing by 8.113 per pollution index. So when it's positive, we have to say increasing. When it's negative, we have to say decreasing. So the fish deaths so that means the more polluted the water is, for each increase in the pollution index, approximately 8 more fish die per year. The fish deaths are increasing by 8.113 deaths per pollution index. Okay, so now it says when p is 0, that means when x is 0, and remember that's called the y-intercept, the starting point. So when x is 0, what is d? So when you put 0 here, that's 0. So you get this, and don't we already know that's the y-intercept? So we don't really have to put the 0 in. You should just be able to go straight there and go, oh, that's the y-intercept, because when I put 0 in there, that term goes away. So it's 107.337. So that means D is 107.337. And what's the label on D? Deaths, fish deaths per year. Okay, last one here. So I'm going to go fast because we only have about 45 seconds here. So this is my X, and it is pollution index. I'll just write P index so I don't have to write it all out. And this is number of fish deaths per year, because this is our Y. So we would say when the pollution index is 0, the number of fish deaths per year is 107.337.